After the new SR-99 tunnel opens, this exit ramp will take northbound drivers into downtown Seattle. It's a small bridge with a big promise, the first in the world built with columns designed to flex back into shape after a strong earthquake.
The vision is, I think, really quite exciting. In the past, the paradigm has been no collapse. That's what we're designing for. In the future, we can be designing for no damage, immediate use by emergency vehicles, commerce, the public. If that comes true, that's a giant leap forward.
WSDOT has decades of experience building and retrofitting bridges to withstand earthquakes. But there are two cutting-edge differences with the design of this bridge.
The first and the most crucial are reinforcing bars called SMA, Shape Memory Alloy. These bars remember what their original shape was.
It's not science fiction. These titanium eyeglass frames use the same technology. They return to their original shape. Building a bridge with SMA rebar is more complicated.
We not only have to have the bars return to shape, but the concrete surrounding the bars. It's a concrete that's highly flexible, has a lot of fibers in it, so that as it moves, it doesn't crack and spall away after the bars have moved.
The idea of combining SMA along with bendable concrete in bridges started 15 years ago at the University of Nevada, Reno's Earthquake Engineering Laboratory, where they test new materials to the breaking point.
The kind of tests that we have done in the laboratory, they have really pushed things to limits. We have simulated very strong earthquakes, well beyond the kind of earthquakes that are likely to occur during the lifespan of the bridge. We typically test our bridge column to magnitude 7.5 and 8.
Standard bridge columns fail under that kind of pressure. But the lab tests prove that columns made with shape memory alloys and composites could be pushed to extremes and straighten up.
Using shape memory alloys, we are bringing the bridge back. We are not allowing the bridge to have a permanent tilt.
Work on the WSDOT bridge columns began in September of 2016. Crews installed the shape memory alloy bars in the top 5 feet of the 2 bridge columns. Crews built the bottom 2/3 of the column with standard concrete. Days later, the bendable concrete went in on the top 5 feet and covered the SMA bars.
We put this at a location where the main motion of the quake will take place, and that's where these shape memory alloy bars will restore us back to the original position. So you don't need it in the rest of the structure.
The federal government endorsed and helped fund the project. It will be studied and assessed to learn more about the promise it holds for future construction in earthquake zones.
We have billions of dollars of shipping every year through the west side of the state, people going to and from work, businesses conducting work. They all need to get around after a quake, and this could be a major step forward in applying that immediately after a quake.